Have you ever heard of a project that was such a colossal failure that it ended up changing the world? Well, today we're talking about an operating system that was so ambitious, so complex, it nearly collapsed under its own weight. But here's the crazy part. Its ideas are probably running on your computer right now. This is the story of Multics, the operating system that failed to die.
Okay, so to get this, you have to understand the vision, which for the 1960s was just out there. The goal was, and I'm quoting here, to create a computing utility similar to the telephone and electricity utilities. I mean, just think about that for a second. They wanted computing power to be like a light switch. You just flip it on and it's there for you. On tap, reliable, for everyone. An absolutely revolutionary idea.
So to really dig into that computing utility dream, we got to go all the way back to the beginning, 1964 to be exact.
Now, this wasn't some little project cooked up in a garage. Oh no, this was a supergroup, a real dream team. You had MIT, the hardware giant General Electric, and the legendary Bell Labs all working together. Their mission? To build this insanely sophisticated time-sharing system for GE's new mainframe, the GE645. The stakes were huge. All right, this is where the story gets really, really interesting. Because while Multics as a product kind of struggled, technically, it was like a crystal ball. It was pioneering features we totally take for granted today, and it was doing it over half a century ago. Let's start with something you literally use every single day. Folders inside of folders. You know, that whole nested directory thing? Before Multics, that just wasn't really a thing in major operating systems. Multics was the one that came up with it. So every single time you click through folders on your computer, you're basically walking a path that Multics paved first. Okay, here's another one. You ever wonder how a bunch of different apps can all use the same system functions, and when you update your OS, all those apps just magically get better without you having to reinstall them? Well, that's dynamic linking. Multics was the first to let a program pull in code from the outside, but only when it needed it. This is the granddaddy of all the DLL files in Windows and the shared libraries in Linux and Mac OS. Now, this next one's a little more technical, but for programmers, it was a game changer. Imagine your computer's memory is your desk, and your hard drive is a big filing cabinet down the hall. Normally, you'd have to keep running back and forth. Multics basically said, hey, don't worry about the filing cabinet. Just pretend everything you could ever need is already on your desk. The OS handled all the messy details. This made programming so much simpler. And seriously, the list just goes on and on. It was the first big OS written in a high-level language, which made it way easier to work on. It was one of the first to be designed with security in mind from the get-go, with hardware support for something called protection rings, a concept that's still fundamental today. And get this, you could add or remove CPUs in memory while the system was running. That was unheard of. Even the command line, the shell, was just a regular program. It was pure, unfiltered innovation.
So at this point, you're probably thinking, okay, if this thing was so brilliant, why have I never heard of it? Well, this is where that incredible ambition ran headfirst into reality, and the story takes a legendary turn.
The problem, in a word, was complexity. Multics was trying to be the do-everything-for-everyone system. It was massive, it needed super expensive, specialized hardware, and it was trying to solve every problem at once. And all that complexity led to delays, which is pretty much a death sentence in the tech world. It created an opening for a totally different way of thinking. Small, simple, focused, and do one thing really, really well. And hey, don't just take it from me. Ken Thompson, one of the key programmers at Bell Labs who would go on to create Unix, he did not mince words. He said Multics was, quote, over-designed and overbuilt and over-everything. It was close to unusable. That feeling, that frustration, that was the spark that lit the fuse for what came next. You can see the whole turning point right here. The project kicks off in '64 with all these high hopes. 5 years go by, it's 1969, and Bell Labs is looking at Multics and seeing something that just isn't working yet. They're fed up, so they pull out of the project. But their programmers, Ken Thompson and Dennis Ritchie, they still believed in the ideas. So that same year, they started tinkering on their own simpler, stripped-down system, and they called it Unix. So even though the Multics product was stumbling, the Multics ideas were about to take over the world. They just weren't going to do it under the Multics name. And the influence was, well, it was everything. Unix, which is the foundation of Mac OS, Linux, Android, you name it, it inherited its most famous features, like that file system and the shell, directly from Multics. You had other systems like Primos that were literally nicknamed Multics in a shoebox. Another one, Stratosphere OS, is a direct descendant that's still being used today because it was built on Multics' principles of reliability. The project might have failed, but its DNA is absolutely everywhere. And you'd think, okay, that's where the story ends. A brilliant failure, a crucial stepping stone to bigger and better things, right? But it gets weirder. A lot weirder.
So for decades, a few of these Multics systems kept chugging along at universities and government sites. But by the year 2000, their time was pretty much up. The very last commercial Multics machine was officially shut down on October 30th. It really felt like the end of an era.
Or was it?
6 years later, in 2006, something amazing happened. The source code for Multics was released to the public for free. A community of die-hard fans and even some of the original developers jumped at the chance. They built an emulator, basically a program that lets you run this old OS on a modern PC. And then the most incredible thing happened. They started working on it again. Active development resumed. And here is the punchline to this whole crazy story. This isn't just some museum piece you can look at behind glass. People are still fixing bugs, they're still adding features. The latest version of Multics, MR12.8, came out on August 8th of 2023. An operating system that was designed in 1964 is still getting updates today.
So what Multics really teaches us is that the line between success and failure can get pretty blurry. Its grand vision was just too much, too soon. But its individual ideas were so powerful that they became the bedrock of almost everything we use today. It basically failed its way into becoming immortal. Which really makes you wonder, doesn't it? What seeming failures happening in tech right now are quietly planting the seeds for the breakthroughs that will change our world tomorrow?